Thank you for that lovely introduction. By the way, it says, I love good, clean software. Just FYI. Anyway, moving on. Today, thank you for coming to my talk, first of all. And today, we're going to get ready to Git Legit. But first, just a little bit more about where I work. I work with Roberto, who you may or may not have seen in the previous slots, at Werkspot. And we are like a marketplace for homeowners and home services. So if you have like a house and you need it renovated, or you need something painted or gardening done, you can go on there and find professionals to do it for you. We're basically active in 3 countries right now, which is Holland, where I am, Italy, and France. And we have about 130 colleagues in Amsterdam, 2 of which are present in this room. As I said, ooh, I should not laugh through my nose in this mic, clearly. Okay, to continue with the order of the day, is this ever you when you tried to work with Git? Because it was definitely me for a good amount of time when I first started using Git. And I promise you after this talk, you can go from this mode to this mode, which is the elite hacker mode that every developer aspires to reach, where your fingers are just dancing over the keyboard and it feels kind of like you're playing the piano. And that's always that unattainable feeling, but I promise you, even with Git, it takes some getting used to, and it will be a little bit painful at first, but once you're used to the whole process, you will reach this state. And basically the foundation of what's going to get you to that state is atomic commits. Who here has heard of atomic commits? Okay, so a fair few hands. And for those who have never heard of atomic commits, it's kind of what it sounds like. If you think about the word atomic, something that is atomic is so small that you can't divide it or it explodes. So you can apply that to commits, and then there are atomic commits. And basically, I feel like there's 3 features to an atomic commit. The first of which is that they have to be a single irreducible unit. So every commit must pertain to only one fix or feature or whatever you're trying to do. So no did this and that and that and that in one commit. So here's a little example. On the left, you'll see an example of a commit that's not atomic. We'll just read it out. It's build sign-up feature, refactored mailer class. This commit holds the entire sign-up feature, controller, repositories, templates, etc. And the mailer class needed some refactoring, I saw, so I just went and did that while I was at it. Now on the right, you see that that same commit has been split up into 3 different parts. If you start from the bottom, first you refactored the mailer class, that's one commit. Then you create all the entity and repository, all the persistent stuff. And then the last one is finally the endpoint. The second point is that everything has to work. So your build can't break on any commit, not just on the PR level, just on any commit, it can't break. Which means that not only does your application run as expected, everything is covered by tests, and all those tests are green. Also linting, no linting errors. Then third, this automatically becomes easier if you keep to the first point, is that you have to be clear and concise in your commit message. So the purpose needs to be very clear from first glance when you look at the commit. And as you can imagine from the first point, if you do this and this and this, obviously if you look at that commit message, it's not going to be apparent straight away what that commit is going to do. So that's basically it, 3 points. That's what makes an atomic commit. And that sounds really simple, and it kind of is, but it will help you with a lot of different stuff. And we're going to talk about a few of the things it's going to help you with during this talk. The first of which is keeping your sanity. That's one of the big ones with Git, as we saw before from that lovely GIF. So let's take a very common thing that usually happens in your Git flow is, so you've branched off from a feature branch. You've created a task branch, right? And then your teammate is working on the same feature, so they branched off into another task branch, and they're done with their task, so they push their code and they create a PR, and it's merged into the feature branch, and now you need the changes that are in the feature branch. You basically have 2 options. Show of hands, who would pull those changes in? Okay. And who would rebase? A few of those as well. Okay. So let's go ahead and look what happens, what the difference is really. When you pull, that's essentially you pull the changes in and you create a merge commit. So you merge those changes into your own branch. So what a merge does is this. You have your base branch, that's the yellow branch, and then you've branched off from that, and then you have those 3 new commits that you've made. A merge commit will just smush those changes together and create a new commit. It will allow you to resolve merge conflicts, and then you have a new point in time where you're synced up, basically. So it's pretty easy. It's one action that you need to take, and then you're done. What's a little less nice about this is that does mean that you have changes from all over the place, so you can no longer really tell what happened in that commit, because you can't say oh, I merged the changes from this bit into my branch. No, because it's from all these different parts, right? So your history doesn't become any clearer from a merge commit. All you can say is merged this. And every time your feature branch has been updated, you have to keep doing this. So you keep polluting your history. Then git rebase. You have the same situation again. You have your base branch, and then you've branched off, and you have your own few commits. And rebasing basically means you kind of rewrite your branch as if you've just checked it out freshly from the other branch. And it does that by replaying all your commits and checking the delta between each point in time. And then you can solve the merge conflict in each point of time and rewrite history in that way, so that all the changes and all the merge conflicts that are relevant to a certain commit will stay in that same commit. And so your history stays intact, your messages stay intact, and everything's still in its relevant little place. Now the issue is, at some point I was told you should always rebase is better. But I wasn't told why or how, and the thing is, I didn't know about atomic commits yet. And if you try to rebase without using atomic commits, you end up with this. You keep getting the same conflict over and over and over again. Now why that is, we'll get back to in a little bit, but that's super annoying because that also happens every time you need to update your branch. And that will cost you literal hours. I have spent half days doing this because I was rebasing without using atomic commits. And that will result in very frustrated developers. I don't know if you know about this website. It's called Commit Logs from Last Night, and it's basically just a feed of, they crawl public repositories for random profanity and make a big feed out of it. It's dead now, unfortunately, but it's pretty entertaining. Anytime I think there's something interesting, like a resource, obviously this isn't a super serious, useful resource, but there will be a QR code, so you can check it out later. So anytime I think there's something worth for you to check out, just take a photo or whatever. So obviously this is entertaining for us, but you don't want this in your history, right? In your open source project or in your business project, that's not great. So the next thing that atomic commits are good for is history. So if you, a lot of people, not just the people that just start out, but I think a lot of people, if not most people, use Git in a way that's quite natural to most people in the sense that they're used to it from other software. So let's say you have a Word document, right? And you write a document and you've been writing for about half an hour, and then you're like, ooh, if Word crashes now, I lose all of my progress. So you save it, and then you type some more, and then you save it. And you keep making these checkpoint saves so that you don't lose whatever you just did. Same with video games. You make some progress, and you're like, okay, if I die now, I lose all that progress, so I have to get to a checkpoint, and I have to save. So it makes sense that you would use Git in the same way. You make some changes, you save, basically. You commit. Make some more changes, you save. So you get this linear thing of okay, did this, then did this, then did this. But then you get situations like these. So start with the bottom commit, right? It says fixed small bug. So there was a bug and you set out to fix it. Then you realize by fixing it, you actually broke something else. So then you have to create a new commit, and you go fixed the fix that I broke something with. Okay, so then you push your code, you create a PR, and someone rejects your PR or MR or whatever you use you're using. So then you address those comments, and you're like, okay, let's make a new commit, address comments, because that's really all you can say. So, et cetera, et cetera, et cetera. And then you end up with all of this, right? When actually, you just wanted this. Because now you have all these different commits, and outside of the scope of your PR, you don't know what's going on. If someone looks into your history and sees addressed more of Dave's comments, okay, but what part of the codes, what comments were they, what's happening? Also, in most of these commits, if you go back in time to any of these commits, you can't be comfortable that your application is actually going to work, because most of these commits capture your application in an unstable state. And there's one more thing, because remember when I said like you'll keep having to resolve the same conflicts if you don't use atomic commits? If you look at these commits, they're all touching the same code. So if you replay all your commits and you check the delta in each point in time, and you have merge conflicts in that point in time, in the same piece of code, then you're going to be resolving the same conflict each and every time. So it would be better to just, if you fix a small bug, if that's your intention, to have just one commit that says fix small bug, everything works after you make that commit and you're done. Now, how do you do that if you've already committed? You can amend your last commit. So you can just make some changes, and then you say like, okay, I want to amend the last commit that I made, and then you can put all those changes that you made new commits for before, put all those in your last one. So this is kind of how that goes. You see there you have one commit. Now I'm just going to make changes. And they're now on stage. I'm going to stage them. And then git commit -- amend, or AM for short, works as well. And then it opens up a text file in your default editor, in this case Vim. And then you can change the message, and then that's it. And you rewrite the history of that commit. So basically, under the hood, Git throws away the old commit and makes a new one. And so it's basically overriding your old commit. That does mean that your commit hash has changed. So if you now try to push this commit to your origin, it will be like, okay, this commit doesn't belong here. This isn't what was there before. So it will reject it, which means that every time you change commits like this, you have to force push. And that sounds very scary, but it's really not. And we'll get back to that later. Now, okay, so that's easy, right? But what if you have a PR with several commits, and someone rejected your PR, and there's comments about changes that are spread over different commits? With amend, you can only amend your last commit, right? So what if there's 3 or 4 commits that you have to amend? For that, you can use interactive rebase. So we talked about rebase before, and how it basically pretends to do like a fresh checkout on the base from the base branch, and it does that by replaying all the commits, right? You can do that interactively, and it'll give you a little bit more control. And not only can you do that onto other branches, you can also do it onto your own branch, like this. This is one of the ways to do it. You go git rebase -I for interactive, and then head tilde however many commits you want to go back. And then it looks a little something like this. So you see the 4 commits in this case at the top, starting with the earliest one at the top. And then you will see that each of these commits is prefixed with pick. And then underneath, you have a little legend with different commands. Now you can change the pick into any of the commands below, and it will not only replay all the commits, but it will do what you said you wanted to do on that commit. So we'll just go through them. Actually, this legend now, I noticed recently there's apparently a new version. This legend now is slightly larger, so there's slightly more options. But so this one is slightly older. But so let's go through them. You can replace pick by the whole command or just the first letter of the command. So first one is pick. which is just replay it as per usual, so do nothing with it. Then reword is it opens the message again in the text editor, and you can reword it just as it says. Then edit basically gives you, I think, the most control because it fully checks out your commit as if that's your last commit, and then you can edit it, like amend like we did before, and you can reword and everything. Then squash and fixup are pretty much almost the same. Squash and fixup both take one commit and smooshes it into the other one. The only difference is that squash will still open the text file with the message, so you can change the message, and fixup will just automatically use the one at the top. Then X is really interesting because you can run any type of command on that commit. So let's say you have unit tests that you want to run. You can use that X and run unit tests on that commit, and you can see if that commit breaks your tests or not, or you can run your linter over it, stuff like that, so you can ensure that all your commits are properly atomic and not breaking anything. And then D for drop is just remove the commit, which means that all your changes from that commit go away. Okay, so with this, again, counts that your history is rewritten, so you have to force push after you do this. Let's look at edit, the one that basically gives you a lot of control. So here's some unstaged changes. I'm going to stash them. Then I'm going to go git rebase -i heads, and in this case, I'm going to go back 5 commits. Then the first one is the one that I'm going to edit, and the 4th one. So now when I write the file, it will check out the first one. I'm going to apply my stash, so there's my changes again. I'm going to add, so stage the changes, then I'm going to go git rebase -- continue, and it will act as the amend. So I'm just changing the message now, and then I write the file, and it'll replay everything, and then stop at the next one that I wanted to edit. And then I'm just going to make some changes, and then also stage them, and do the same thing. So now, any changes that were part of that first commit and that 4th commit are now nicely packed into the commits that they're supposed to. And I've rewritten my history, and now I can force push, and we're all good. So you don't have those weird little checkpoint commits that don't really say anything. So another thing that atomic commits are good for is code review. So when you're not using atomic commits, what I did on GitHub is you have those tabs, right? GitLab is quite similar. And you had the files change tab on the right. And I was like, well, that makes sense because I want to see what changed, right? So then I go to the files changed, makes sense. But as you can see, there's 30 changed files in no particular order, with no context other than the really broad context of the PR description. So you're going through these 30 files, and you know that feeling when you're reading a book and you're kind of zoning out, and then you're like, you go halfway down the page, you're like, okay, I wasn't paying attention, so I have to go all the way back, and then you have to reread it a whole bunch of times before you actually really know what's going on. So not only is that kind of a time waster and really boring, it's also not going to make your reviews very good. Now with atomic commits, what you can start doing is you review commit by commit. So what I do is I just go to the commits, and then I just like command click, so it opens in a new tab, and then I go tab by tab and commit that and review that way. The reason you can't, well, you can physically, but the reason it doesn't really make sense to do that if you're not using atomic commits is, let's say you see a bunch of changes that you disagree with in the first commit, then you comment on that, then you go to the next commits, and then by the 5th commit you see that that thing that you commented on was already fixed. With atomic commits, that doesn't happen because all the changes that are relevant to one part, one thing, are all in the same commits. So as you can imagine, this whole thing only works if your whole team is doing it. So set a standard and call them out. A little bit about messages. Because then if you go commit by commit, you have not only the PR description, but also every commit has its own little context. So you get the commits that, so you have kind of like chunked up information, and you have at the top, you have exactly what you're looking at. So it gives you a little bit, it gives you all the information that you need and gives you a little bit more context, which is going to make your life a little bit easier and your reviews a lot better. So this is how we generally do messages as a standards. There's lots of different standards. A lot of people prefer to put the issue number, for instance, in front of the subject line or in the description. Some people use Gitmoji, which is basically you set a standard for what an emoji means, like, oh, this emoji means it's a bug fix, or this emoji means it's a task. And they put that in the subject line, so at first glance you can see what it is as a team. But we just have this. The generally kind of accepted guidelines are these. You separate the subject from the body with a blank line. That sounds quite arbitrary, but we'll see why that's actually kind of important in a minute. Some of these are a little more arbitrary than others, but you'll figure that out. And again, there's a QR code to an article here that has a lot more information, super practical information that's not going to be in this talk, so I definitely recommend checking that out. So number 2 is you limit the subject line to 50 characters. There's similar reason for that we'll see in a minute, but also it just forces you to make kind of like a concise description of what you've done in that subject line. You capitalize the subject line, a little more arbitrary than others. This one also, you don't end the subject line with a period. It's just kind of to set a standard, I suppose, and also it saves you 1 character, I guess. Use the imperative mood in the subject line. So what a lot of people do is they say, added this, created this, or creates, or fixed, or so the imperative mood means that you go fix, create, add. So not only does that save characters, obviously, but it's also a bit more direct, so it reads a little bit easier. So if you set that as a standard, it just makes your subject lines a little bit more palatable. Then wrap the body at 72 characters. It's good to wrap it somewhere at least. 72 characters does have, I've been told, a historical reason to wrap it at 72 specifically. But either way, it's quite important to wrap the body at some point, because if you don't do that, you'll have these really long lines. And then when you get to the end of the line, you get to do a whole horizontal scroll back and start at the next line, which is super annoying. So it's nice to just have that little box. It's more readable. And then this one is a pretty big one that a lot of people have opinions about. You use the body to explain the what and the why versus the how, which is to say you describe the what and the why, and you don't describe the how, because the changes should already show you how it's been done. So what I always do is in the subject line, I say what I've changed, and in the description, I say why I've done that and why those changes were necessary. So, example, again. If you keep to these message standards, you can have nice logs. So on the left, you'll see git log, just your regular git log. So you'll see the subject line and then the blank line. So the subject line has the what, and then the blank line, and then the description has the why. And then you'll see exactly why you need that 50 character limit on your subject line and the blank line underneath. Because if you use git log --1 line, which I actually use a lot to just get a really quick overview of changes, then obviously that's not going to work if your subject line is really, really long, because it's just going to cut off at some point, so it's going to be half a sentence. And it's also not going to really work if there's no blank line underneath, because it won't know where to cut that off. So that's one reason. So you might think, that's all nice, the 50 character limit on the subject line and 72 character line wrap, but do you expect me to just count every time? No, of course not. There's configuration files for that. So if you follow this QR code, there's a bash profile and a vimrc, I think, and another one I can't remember. That will, if you put that configuration in your own machine, it will automatically wrap the body it will show you if your subject line is too long, and it will add git completion, bash completion, so you can just tab and auto-complete your branch names, which is super nice, and your commands and stuff. There's a bunch of other stuff there that I didn't necessarily need, so I took it out, but it's really handy. And I would like to thank this guy for that. I don't know if you know them, but that's Luis Cabucci. Thank you, Luis Cabucci. That's his gist. So, some other quick wins. Was that a warning? Time warning? No, that was just a beep. Okay, good. I was like, that's fast. So some other quick wins that you'll get from using atomic commits is one of them is cherry picking, because let's say you have your teammate working in parallel to you with another branch, and you don't need all of the changes in that branch, just a few. Because your teammate has presumably kept everything atomic, you can just pick one commit from their branch and put it in yours, and it probably, much less likely, won't conflict with anything. It'll be easier to remove because it's not linked to anything else, because it's just its own thing, contained thing. So that's really nice. So this is how you do it. Let's say this is the one I want to cherry pick. This is someone else's branch. I copy that hash. Then I check out my own branch again. And then you'll see I have 2 commits on my own branch. And then I go git cherry dash pick. And then I paste the commit hash. And then if you look on my branch, you'll see that commit is there. Use this sparingly, by the way, and drop it when you're ready to actually rebase. Otherwise, those 2 commits might conflict with each other. But if you just temporarily need those changes, then this is super handy. Then another thing is you can start dropping stuff really easily for the exact same reasons, because everything is contained to its own little thing. Now, I found that this is particularly useful in situations where, for instance, when PHP 7 happened and there was strong typing everywhere, that I would make some changes in some class, and then I'd be like, oh, this isn't PHP 7 proof yet, so I'm gonna add the strong types here. And then what I did was I'd put that in a separate commit, and then put all my other changes in another commit. And then you'll see sometimes when you do these things, and not everything is amazingly covered, that actually there might be places in your application that call these methods or whatever it is that aren't using the right type, so that stuff breaks. Now, if you would have put everything in the same commit, you then have to go back and manually undo all those changes to the argument types and stuff. But because it's in a separate commit, you can just go, and it's gone. So that will take you from what would have been like 5 minutes to 2 seconds. So this is how you do it. You may have seen it already in the interactive rebase before, but there's an even easier way. So let's say I want to drop this, refactor some class, that broke something, so we don't want that anymore. We go into our interactive rebase, and you can just delete the line. You don't even have to use the command. So that's how easy it is. Just delete the line, write the file, and then the commit is gone. Now, another one that's a big one is git bisect. This is always a little bit of an enigma to a lot of people. And what might also be a bit of an enigma to you is why I've chosen to put an egg emoji to start talking about git bisect. But that is because the bisect part of git bisect stands for binary search. And I find that explaining binary search is easily done using a bunch of eggs and a building. Now, let's say you have a situation where you have to find out what the first floor is that you drop an egg from, and it breaks. Realistically, it's going to be the first floor. But hypothetically, in this imaginary world, you have to figure out which one that is. So you set about doing that, and you go to the first floor, and you drop one, and it doesn't break. Okay, so let's try the next one. Okay, it doesn't break. Then you go upstairs again, upstairs again, upstairs again. Oh, there it breaks. So that's taking you a bunch of tries. Now you can imagine that if this building is 50 stories tall, You might be really lucky and it might break realistically on the first floor, but it might also break on the 50th floor. So that's going to be a bit of a time waster. A different approach that's more efficient is to start in the middle. So now you start in the middle and then the egg breaks. So you know that in between there, somewhere in between there and the floor, is the first point at which the egg is going to break. So then you go into the middle of that. You see it doesn't break there. So then you know it must be in between there somewhere. So then you go into the middle of that, it breaks, and then there you have it. So you can do the same thing with your application. If you have a whole bunch of commits, for instance, okay, so your application has a button somewhere, and you know that a month ago that button was in the right place. And now you look at your application, and now the button is not in the right place, but over here. You know that somewhere in the last month this went wrong, this happened somewhere, and you have to figure out where. You can try to dig in the code, you can try to check out each commits and rerun the application, but you can also use git bisect for that. And this sounds like something you won't use very often, but I've used it so many times and it saved me so much time actually that, yeah, you should definitely try and check it out. So, okay, this demo is a little bit faster, so we might have to replay it. And it's a little bit more complicated, but we're gonna go into git bisect now, and we're gonna assume that we already have the commit that we know was still good copied, okay? So let's go. We go git bisect starts, and then we go git bisect good, that commit hash. So that's a good one. Then our last commit was the bad one. We know that the button's not where it's supposed to be there. There you go, git bisect bad, that commit. And then it will check out the middle. And then you run your application, you see if the button is where it's supposed to be or not. And you say, okay, it is right there. Okay, so you go git bisect good. Then it checks out the middle again, you see that it's broken, git bisect bad. And then it takes a lot less iterations to figure out which commit is the broken commit. And when you're done, you go git bisect reset, and it'll spit out the commit hash that broke your application. Now, again, you can imagine if there's like, this is obviously not very many iterations, but you can imagine if it's like 150 commits, which is easily accomplished in like a month, depending on your how many commits you make and also how atomic they are. It's going to be a lot faster than having to check out each and every commit and digging into it. So that's really nice. If you want to test this yourself, by the way, it's quite nice to just get any random open source package. Just go to a random point in the history and break a unit test, and then go further back in history, and then just try it out a couple of times. And you just run the unit test every time you check out a commit, and mark it good or bad, and then, yeah, it's a lot easier than it seems. So, before we go to the slides, I don't know what the thing is called. Slido? Yes, the Slido questions. Obviously, there's a lot of skepticism probably in the room about this, and I know that because I had a lot of skepticism. So before we go to those questions, I want to take away some of the initial skepticism that I had when someone came into my team and taught me all of this. So, but how do I call people out on mistakes? Because you're rewriting history. So in that initial fixed bug scenario that we looked at, we can't go back and see, oh, you actually didn't fix that bug the first time. You actually broke it. But then when you rewrite history, you can't do that anymore. But then I'd like to like kind of counter ask what the point is of source control. Is it to point fingers or is it to control your source? Because if you take a textbook, for instance, you take the latest edition, right? You want the most up-to-date information. You're not going to sit there with the first edition, go page by page and compare and see like, hey, see, there's a spelling mistake there. There's no real point. You want to make sure that, you know, the advantages are bigger in this flow than the other flow. And the advantages are you can revert back to any point in time and you can be confident that your application is going to work. You can search in your history It's really easy to see what happened and where. So there's all these different advantages that I think far outweigh being able to see and point fingers on rewritten history. Another big one is, how will this affect my flow? Because obviously the merge thing is way quicker. You just merge once, you solve the conflicts, and then you're done. So rebase sounds a little bit ridiculous, but it really doesn't have to be that crazy. If you're used to those checkpoint commits, you can still, on a Friday night, you might want to grab a beer, you might want to go home, you have to hurry, and you still want to push all your changes, but you don't want to go into like cleaning everything up. So you don't have to, actually, as long as you clean up your commits before you want to merge it. So in that respect, you make a distinction between your private branch, which is the one that you're working on, and nobody else. I never work on one branch with a teammate. They always branch off. So that's your private branch. And then your public branch is master or whatever you use. So you make sure that before it goes into master, it's cleaned up. As long as it's your private branch, you can make it as gross and messy as you like. So this is basically what I do at the end of every workday. Let's say I have to go home and I just make a big checkpoint commit and I decide to clean it up later. So here you'll see a massive commit for a day's work. Then I'm just going to go and reset that. So all the changes become unstaged. Now you'll see handler. Okay, we know that the last commit now was something about a handler. Right. So then we add the handler there and just amend to that commit. So that's where it should be. And then we're still left with a bunch of changes, namely bug fix, feature X, and relevant to feature X. So we know where those are supposed to go, presumably. So you stage feature X and the other one that's relevant to feature X, and you make a temporary commit out of that with just a messy name. Doesn't matter, doesn't have to be pretty. So you just go git commit -m feature X. And then you do the same to the bug fix thing. Just make a temporary commit called bug fix. And then you go into your interactive rebase. This is one way of doing it, by the way. There's faster ways. There's all kinds of different ways, but this is one way. This is what I often do. So you see those two commits. You cut them and paste them after whatever commit they're supposed to be put into. There you go. And then you change pick for F, which we talked about before, which will just smush them into the previous one. And then you write the file, and it's just gone and rewritten all that history, and then it's all clean. So that takes you maybe 20 seconds. So you can still have keep your old flow and be as messy as you want, as long as you clean up later. Then, the big one, isn't force pushing scary? And it is. It can be. It can be. So what happened at a company that I used to work for is someone was a little bit tired and she forgot to check out a task branch and she was just working away. Maybe she got distracted or something, just working away and then force pushed to master because she never checked out her own task branch. So obviously that's not great when you have a CI/CD type of situation also. But so that was actually kind of our fault because we should have protected master, because you can't expect in a team of, let's say, like 20, 30 developers that everyone's going to be super alert all the time and not make these kinds of silly mistakes. So I'm a big believer in like kind of protecting your developers, who are generally very smart people, against tiny mistakes that anyone can make. So no force pushing isn't scary because you have protected master or any other type of important branch. And because you're on your private branch, your own branch, you can force push whatever you want. It's going to be your changes. You're not sharing that branch with anyone else, so you're not overriding anything else. And if you're really worried about losing your own stuff, you can always just quickly make a local copy of your own branch, or you can even use reflog to go back in. But that's a story for another time. But that's also a good way to undo your mistakes. And with that, that's all the skepticism that I had. So let's see if there's still time for the Slido questions. Thank you.
would say it has something to do with you, because we have
Oh,
a lot of
God.
questions, which wasn't last time.
Okay.
We had a guy here talking, but it's okay. Do you recommend using terminal for Git as a good practice or some kind of GUI in Ubuntu?
Okay, so I actually don't have any experience with GUIs in Ubuntu and very little experience with GUIs for Git in general. But I find terminal to just be fine. It's as soon as you're used all the commands, it's probably the quickest. I know some people tend to use GUIs as well, but the GUIs that I have used in the past seem to be a lot more limited and just felt a little bit slower. So I'm a fan of terminal.
Okay, next question. What is your preferred merge strategy? Would you recommend Git squash?
Yeah, I get this question a lot. We actually talked about it yesterday with the group. I would again counter that question with why do you want to use squash? Because the answer that I usually get is because they want to do some sort of versioning type concepts. Like they squash it because they want to just go like, we built this feature. No, but we built this feature and we want to just like, we want to just like have that like in a package and go like, this is where we finish that feature. And that's the only reason why they want to do that. But you can also do that with version tagging. So, and then you can still see which point in time you release something, and you still keep the entire history with the description and everything. So you still have a more detailed idea of what happened in your history.
Third question, how do you handle situations where one team member uses rebase and commits atomically, I'm sorry, but another uses merge and commits in a non-atomic way?
Yeah, so that doesn't work. That's not going to work.
You send it to your talk.
Yeah, exactly. So it would be good, I would think, to just have a standard with, that's always, communication is always hard. But I think it would be good to just like have a common understanding of, you know, and a common agreement of why we prefer one or the other. And as soon as you set that standard, as with any standards, keep to it and call people out. Well, that sounds very aggressive, but just, you know, keep people to it and just go like, oh, remember to keep it atomic.
That's the most difficult part.
Yeah, that's always the most difficult part, unfortunately, but yeah.
Do you know a good way, existing tool, how to integrate those mentioned commit best practices, e.g. title length into CI?
Actually, no, we don't currently have any, but I'm sure you could probably do it, because you have, huh?
Hooks.
Yeah, exactly. So, well, yeah, that wouldn't necessarily be CI, but you do have hooks, like Git hooks, that you can, is basically little scripts that you can run before a commit, after a commit, after a push, or, well, I don't know why you would want to do that, but I think that's something you can do. And you could do things like, oh, automatically run the linter after I commit something, for instance, or before I commit something. It's kind of useless to do it after. So you can do that, and I'm sure you could do it for your CI pipeline as well, but I don't know how.
Okay. Do you use different merge strategies for different branches? Example, develop branch in a rebased, and the master should be always merge, not rewrite history.
Yes, yeah. So master, I don't think there's any reason ever to push to master. So
Is it squash merged or just merged?
just merge with fast forward. At least
Why
that's
not
how.
squash merged?
We just had this question.
No, I mean, you had this question for branches, not for master.
Oh no, but that's the same. That's I assumed that was about master anyway.
Okay.
But it's the same thing because usually the reason people want it is to have some sort of versioning thing.
All right.
Yeah. So yeah, it's the same same deal. Yeah. So master, I'm a fan of just having fast forward merge into it, never push to it.
Code review doesn't benefit from atomic commits on GitLab. Any suggestions?
It does. We use GitLab and we still review commit by commit. So I'm curious as to why that would not work.